Today we'll look at three modes of heat transfer, and in accordance with the second law of thermodynamics, we found that heat is transferred from the hotter to the colder body. And as we know by now, heat is the process through which thermal energy is transferred between bodies and thermodynamic systems. So the first mode of heat transfer is conduction. Now suppose we heat one side of this block to some temperature we'll call TH, and we want to determine the rate at which heat is transferred from one side of the block, so the hotter side, to the colder side. So if we suppose this is a metal block, then the electrons are basically going to be free to move around, so they're effectively going to transfer kinetic energy between each other. So effectively the electrons with a higher energy are going to transfer that energy to the electrons with the lower energy. So therefore the heat is going to flow in this direction from the region with the higher energy to the lower energy region. And we can define the rate at which heat is transferred, which is in joules per second, and that's equal to the thermal conductivity of the material multiplied by the cross-sectional area multiplied by the change in temperature over the thickness of the material. Now the thermal conductivity has units of watt per meter Kelvin, and I encourage you to actually determine that from the units of these quantities given in this equation. And this here depends on the ability of the material to conduct heat. So as we can imagine, because a metal has the electrons free to move around, so the thermal conductivity of the metal is going to be greater than that of a ceramic. So for example, ceramic has covalently bonded carbons to silicon atoms, so the electrons are not really free to move around in a ceramic as they are in a metal. So that makes sense that a higher thermal conductivity of the material results in a higher rate of heat transfer. Now the next quantity we look at is the cross-sectional area. So heat's going to flow through the cross-section of the material. So this rate of heat transfer can be interpreted as a heat flux, which flows through some area. And the larger this cross-sectional area, the larger the rate of heat transfer, which also makes sense. And now the next quantity is the change in temperature, which is equal to the difference between the hotter and the colder temperature. And delta T on L can also be looked at as a temperature gradient, which is a change in temperature over the thickness of the material where the heat has to travel. So this will be the L dimension. So that also makes sense that if we have a higher temperature gradient of delta T on L, then we have a higher rate of heat transfer. And if we look at these quantities individually, well, a larger difference in temperature will give you a higher quantity for delta T, which will also yield a higher rate of heat transfer, whereas the distance through which heat has to travel through the material, denoted by L, so if this quantity is higher, then that's going to result in a lower rate of heat transferred through the material. So really have a think about this, and now we'll move to the second mode of heat transfer, known as convection. And this is heat flow basically through a fluid. So if we have a heat source that heats up the neighboring air particles, then the density of air in this red region is going to be lower than the density of the air above it. And recall the concept of buoyancy when we looked at fluids. Well, the less dense air is going to basically float on top of the denser air. And therefore these air particles with a higher energy are going to transfer heat through the fluid by buoyancy. So you probably experienced this. If you put your hand some distance above a candle, you'll still feel the heat coming from that candle. Now the final mode of heat transfer is radiation, which is heat transferred over a very long distance. So for example, if you have the sun, that transfers heat through electromagnetic waves, which are known as light waves. So the higher the frequency of these waves, the higher the energy or heat transferred. And I'll see you in the next video.